everyone. Today we're starting our last chapter for general chemistry, chapter 20. So we've come a really long way this year. So this chapter is all about radioactivity and nuclear chemistry. So what is radioactivity? Radioactivity is the emission of subatomic particles. So remember, those are things like neutrons, protons, electrons, or the emission of high energy electromagnetic radiation. So remember, a long time ago, we learned about the electromagnetic spectrum and how it's made up of different waves or waves with different energies. So we had kind of low energy waves like microwaves or radio waves. And then we had high energy waves like X-rays or gamma rays. So in particular, gamma rays are related to radioactivity. So both of these things can be emitted by the nuclei of certain atoms. So for instance, if an atom is really unstable, then it's going to release some energy in order to become more stable. Now, atoms that emit radiation are said to be radioactive. Now, radioactivity has a lot of different applications. So, for instance, it can be dangerous in certain applications, but it can also be very helpful, for instance, in medicine. So nuclear radiation is used for diagnosis and treatment of medical conditions. If someone has cancer, they might use, the nuclear type of radiation to help cure it or get rid of a tumor. Additionally, you might just need to see if something's wrong. In your textbook, the author uses an example where he thought he had appendicitis and he ingested something that would essentially glow or show up on an X-ray to help diagnose whether he had appendicitis or not. So nuclear radiation can be really useful. Additionally, naturally occurring radioactivity is used to estimate the age of fossils, rocks, and ancient artifacts. So on the right-hand side is a picture of what are called trilobites. And these little guys were alive even before dinosaurs. So they did eventually die out. So one of the mass extinction events killed them all off, but there is evidence that they existed in these fossils, and we can use what's called carbon dating to determine just how old those fossils are. So we'll talk more about that later on. And radioactivity also led to the discovery of nuclear fission, which is used for electricity generation and nuclear weapons. So again, radioactivity can be quite dangerous and used for evil purposes, but it could also be used to help power our homes, our businesses, etc. So let's talk about how radioactivity was discovered. So there are some chemicals or molecules that when they're exposed to sunlight will still glow if they're put into a dark room. So if you've ever had, for instance, like little toys or when I was younger, I had those glow-in-the-dark stars that you put on your ceiling or your walls. So those phosphoresce. So those contain compounds that absorb light and then reflect it for a certain amount of time in the dark. Now, a French scientist, Antoine-Henri Becquerel, he designed an experiment to determine if phosphorescent minerals also gave off X-rays. So phosphorescence in particular is the long-lived emission of light by atoms or molecules that sometimes occurs after they absorb light. So off to the right is a little picture of a toy that phosphoresces. And one molecule in particular that phosphoresces is zinc sulfide. I don't know if that's what's in this toy, but that is one example of something that can absorb light and then reflect it. Or I guess reflect isn't the right word. It emits it. Now, X-rays are detected by their ability to penetrate matter and expose a photographic plate. So off to the right is another picture, and this is actually one of Henri Becquerel's original experiments, and you can see some of his notes at the top. But this is a photographic plate, and there's a couple of dark spots on it, and that's from some molecules that were giving off enough energy to expose the photographic plate. So what Becquerel did for this experiment is he placed crystals that were made of potassium uranyl sulfate, which are known to phosphoresce, on top of a photographic plate that was wrapped in black cloth. Now what he found was when he shined light on the crystals and then took the light away, the crystals left dark spots on the photographic plate. However, later on, he kind of had an accidental experiment where he just left a photographic plate wrapped in paper in a dark drawer, and he placed one of those crystals on top of it and then just left it in the dark drawer, and he had not exposed it to light. When he pulled out that photographic plate later on, he found that there was still a dark spot on it. So that showed that the crystal was still emitting energy, even though it hadn't been exposed to light. And then that led to his discovery of radioactivity. So Becquerel discovered that certain minerals are constantly producing energy rays that can penetrate matter. So Becquerel determined that all the minerals that produce these rays contained uranium. So uranium is what we call radioactive. And the rays were produced even though the mineral was not exposed to outside energy. So uranium has internal energy that it's giving off. Becquerel called those rays uranic rays because they were emitted from minerals that contained uranium. So this is very similar to X-rays, but it's not related to phosphorescence because phosphorescence requires light or outside energy. So uranic rays don't require outside energy. Oh, apparently I can't change my slide here. Let's see if, oh no, it's all paused. Let's see if I can reopen this. Oh man. There we go. Technical difficulties, of course, during the last week. All right, so another scientist named Marie Curie determined that these rays that Becquerel discovered were emitted from very specific elements, and not just uranium. She also discovered that an element named radium gives off this energy, and also polonium gives off this type of energy. So radium was named for its green phosphorescence, and polonium was named after Marie Curie's homeland of Poland. So Marie Curie's shown off to the right with her two daughters. One of her daughters actually went on to become a physicist, and her other daughter wrote a biography about her mom. But also Marie Curie and her daughter both won Nobel Prizes in chemistry, which is really cool. I I think Marie Curie's the first female scientist we've talked about in this class because there weren't many female scientists when things were being discovered, or at least they weren't given credit. Okay, so because these rays were no longer just a property of uranium, Marie Curie renamed these uranic rays as radioactivity. Now, Marie Curie's husband also did a lot of work with her on this. His name's Pierre Curie, but he died fairly young, so a lot of the work on radioactivity was done by Marie Curie. So let's talk about radium a little bit. Radium has an interesting background. Radium was initially used in many different objects due to its glowing effect without needing to be recharged or exposed to sunlight. And it wasn't fully understood why radium did this. It was just thought to be magic. So people would actually wear watches with radium painted on the hands there and the numbers. And then also women would use radium in their hair. They would actually wear nice dresses in radium factories so that their dresses would glow when they went out later. Now, the women who worked in factories with radium started to feel a lot of pain in specifically their jaws because they were painting radium on different objects, but in order to make their paintbrushes really fine so that the point was really small, they would lick the brushes. So they were licking radium and ingesting it. So the radium was actually really dangerous because of its radioactivity, and it was causing women to have jaw pain, and eventually a lot of these women passed away. So radium was finally found to be deadly and was eventually outlawed from manufactured products. There is an article down below that talks a little bit more about radium, and in particular the women who worked with radium. There's also a book that came out recently called Radium Girls, if you're interested in the history of that. So let's talk about why radium and other elements that are radioactive are so dangerous. So Rutherford, you might remember him from the very beginning of our chemistry course. He discovered 3 types of rays. He discovered alpha rays, beta rays, and gamma rays. And you can see that they're each given a little Greek symbol. So these main types of rays have different properties. So alpha rays, for instance, have a charge of +2 and a mass of 4 atomic mass units. So that's actually equivalent to a helium nucleus. Remember, helium has a mass of about 4 AMU. Beta rays have a charge of -1 and negligible mass. So that's pretty similar to an electron. And then gamma rays are actually a form of energy. They're not a particle. Now, in addition to those 3 types of rays for radioactive decay, some unstable nuclei will emit what are called positrons, and these are very similar to a positively charged electron. So it's something that doesn't have mass, but is positively charged. So it's not really like a proton because, again, it doesn't have mass like a proton. So we tend to think of it as a positive electron. And then some unstable nuclei will undergo what's called electron capture. So an atom might actually pull in an electron into the nucleus. So these are all different types of radioactive decay. All right, so I think next time we'll go over how to actually analyze isotopes of these radioactive elements. You know, how do they emit these different rays? How do they undergo these different processes? So we'll talk more about each of those different types of rays in detail and how to write what are called nuclear equations.